Welcome to the Tech Field Day podcast, where each episode we bring together a group of IT experts from a variety of technology fields in enterprise IT to discuss relevant topics in the industry. This podcast is brought to you by Tech Field Day, a part of the Futurum Group. Before we jump into the premise for today's episode, I'd like to take a moment for our guests to introduce themselves, starting with Mark.
Hey, I'm Mark Houtz.
Kerry Kulp.
Scott McDermott.
All right, thank you all very much for joining us. Let's jump into the premise for today's episode. We all buy our technology based on a certain amount of assurance that it's going to do what we want it to do. We want our laptops to be a little bit faster than the one that we're replacing. We want our phones to be a little bit faster with a little bit better battery life. But how do we know that those numbers are actually what they say they are? And there's no bigger offender of that than the wireless industry, because the numbers that get printed on the back of the box sometimes don't match up with what we meet in reality. So the premise for this episode of the Tech Field Day podcast is that all Wi-Fi marketing numbers are lies. Yeah, I know, you're probably already saying, well, duh, Tom, nobody ever gets those numbers. But I guess the question would be, why do those numbers get put on the back of the box in the first place? Kerry, I think you had a really good answer for this when we were discussing it before the podcast started.
Look, it's all marketing. It's all. I will forever rue the day that I chose a technology that is marketed to consumers as my chosen path. They put those numbers on there purely for consumers. You go to Best Buy, pick out your router that does 7 gigabits per second. Nobody ever gets that. It's not reality. And every CIO reads them. Every CIO thinks it's possible.
Well, I'm just curious about this because we all know that I have a background in wired networking. Well, the cables that I plug in are gigabit, and that's all they do is gigabit. Why is there a difference?
When it comes to wired, it's constrained within a cable. Wireless, you have interference from anybody around you, and so that affects it. You have in theoretical perfect conditions inside of a chamber with one AP, one client. You can reach close to those speeds. Even in those pristine conditions, you're not going to hit it perfectly, but you can theoretically get up there with all the bells and whistles turned on, one client perfectly set up. You add 2 clients to that, it cuts it in half, and every client you add onto that reduces your throughput, and so it theoretically hurts those numbers. So even in a home environment, you're not going to have one device on there.
I mean, it kind of is the purpose of me having a wireless router in my house is so that all of my devices don't have to plug into things, right?
Can I ask it differently, though?
Okay.
When was the last time you saw marketing that told you how fast that wire is going to be?
As far as I know, other than saying it's a 10, 1000 Ethernet port, or in some cases, multiple gigabit port, very rarely does anybody say, unless you're doing like a data center operation or something.
This isn't really new to Wi-Fi either, because I remember the first time I noticed this was back when 100 meg was new and full duplex was new, and there were switches coming out, and they're like, it's a 200 megabit port because you get 100 megabits each direction. I'm like, no, that's not how it works.
But if it's 100 megabits and there's 2 channels, it must be 200 because the math is mathing. Except it's not, because that's one of the things that we've learned is, well, go look at your car in your garage. Does the speedometer stop at the speed limit, or does it go way far beyond that? And a better question would be, for most consumer vehicles, why does the speedometer go past where the engine is governed to? Because I've seen minivans where the speedometer goes to 120 miles an hour. You will never get that thing. No, because once that minivan hits a certain speed, it's an engine governor, it cuts all RPMs. So it really cannot go that fast. But yet, when you ask the car manufacturers, well, we put it on there so that people think ours is better. So is this a situation where even though the manufacturers know they're never going to get those speeds, they put them on there anyway because this is what our customers want?
Well, I mean, a lot of the numbers are based on the standard, right? So we've got theoretical numbers that you can potentially get to, and the hardware does technically do that. It's just outside of a home that's in the middle of nowhere and has no neighbors, I mean, it's not actually a realistic deployment. It's certainly not in the enterprise. We're not going to deploy anything that gets even remotely close to those numbers, even from a theoretical basis, because we can't do a good Wi-Fi deployment in that case.
You're also relying on the clients to support full, because the standard talks about 16 by 16 radios, nobody has them. 8 by 8, nobody has them. Outside of a few cases, nobody has those type of radios. That's to get the maximum. Then you have to have the other side that supports it as well, the client side, where typically these are iPhones or laptops or something that do not have the space to put that many radios, let alone they're running on battery. And so you have things that drop your ability there. And so you're never going to hit these standards. We have Wi-Fi 7. Wi-Fi 7 is better than 6. What is Wi-Fi 7? It's high efficiency, not
AC. Wi-Fi 6 is high efficiency. Wi-Fi 7 is extremely high throughput.
That's right. That's right. And so you have these standards that are focusing on different things. We were going for speeds, high throughput, Wi-Fi 5. I don't remember that. Wi-Fi 5, high HT, high throughput. We're going for speeds. Now the industry is going, well, we can't push speeds. Let's go for the next metric of efficiency, reduce that latency, because cellular is trying to come in and take over that. So let's change to that mode. Those numbers continue because that's what we've trained the consumers on, that 7's better than 6, which is better than 5. So we have to keep pushing those numbers.
But it's okay to say, I'd be perfectly fine if they just said Wi-Fi 7 is better. But when they say that you're going to get 7 gigabits, and to get 7 gigabits, that means that we have to turn on 320 megahertz channels, which I saw somebody post the other day, something I completely agreed with, like the change my mind thing. 320 megahertz channels are a bad idea, change my mind. I'm not going to change your mind because I completely agree. But somebody commented, I've never seen Wi-Fi not work with the maximum channel width. Then you haven't done enough of it, because that's the problem. When they market it performance oriented that way, and that to achieve those numbers means you have to turn on 320 megahertz channels and all the other stuff that just makes it difficult.
You have to make decisions that make bad Wi-Fi designs.
Right. Yes. But here's the problem. It's for those that know, they don't make those decisions.
Right.
But almost all of those that know report to somebody that doesn't. That somebody that doesn't says, well, I want that. I need that. Of course we need that. And I to this day, on the channel width topic, I contend that we almost never need wider than a 20 megahertz channel. Performance is almost always more than adequate on a 20 megahertz wide channel. And we can drive capacity on the network so much higher if we just keep narrow channels, push the overall capacity up.
You can stream 4K video. You can stream 8K video.
You can do
megahertz channel.
Almost everything. The only thing that I've ever really run into is raw PACS imaging in a hospital that could use more bandwidth. And even at 20 megahertz, it's still good enough.
But when you go wider, that does allow the clients to get on and off
the air faster, for sure. So there is efficiency.
Yeah.
Right?
Well, and because we've got that constrained medium, it's like we're sharing that medium, so we've got to. Everybody's on the same channel because it's like a giant hub.
But so when you think
there can be advantages, but it becomes very use case specific.
But the reality, I think, and again, data would probably show that I'm not entirely right here, but driving up capacity overall in the network eliminates a little bit of the need to get clients on and off the channel faster because they're spread out more, they're balanced across more APs. It's just one of those, it's kind of a pet peeve of mine. I can't stand the marketing of the numbers of Wi-Fi.
But at the same time, and this is something that I've run into in my own research and writing, when the M1 MacBooks came out and everyone was freaking out because, the Wi-Fi is slower in them. Well, yes, because you're using a more advanced 2 spatial stream card as opposed to the 3 spatial stream card that the old one had. And it was 100 megabits per second slower at theoretical max. In reality, you won't be able to tell the difference because you're not going to be pushing it to the absolute theoretical maximum with your crappy home network setup. And how do we measure those things? Do we use iPerf to go to a local device that's connected to the same AP? Or do we go to speedtest.net, where we're at the mercy of the internet and all of the latency that we have to deal with there? And how many times have we seen the Wi-Fi get blamed for, the IPv6 TCAM table overflowing on a switch at a large vendor conference? So there's a lot of things that go into this, but what really matters to people is not the, to quote Sam Clemens, it depends methodology, but the box says it does this. Why does it not do this? But to be fair, that's not something that is specific to wireless. If you don't believe me, check out the throughput numbers on a firewall, which are all lies as well, because they specially craft 64-byte packets to get their maximum packets per second throughput, or battery life. Because there isn't a soul on this planet that believes that when Apple says that that new iPhone will get 12 and a half hours of battery life, what they didn't tell you is that the screen is turned down to 1 lumen and it is playing a video in Safari that has been optimized for codec. In reality, yeah, you're probably lucky to get 8 or 9 hours out of it. And a lot of organizations like Consumer Reports have gone to the length of saying, we're going to test the battery ourselves and give you real world numbers, not theoretical numbers. Should there be a situation where standards body or an independent body says, well, these are lies, here's what you can really expect under average conditions. And what are those average conditions? Multiple clients connected to the same AP, interference sources, concrete walls filled with rebar everywhere.
Yeah.
Even one building that's designed specifically to be the same has different environment, neighbors or other things like that.
Well, and then back to the client thing, it's like, what client are we using? You know, is it the Pixel 9 with all of the fancy features, or is it, you know, an iPhone 5? I mean, you're going to get radically different numbers.
How many times was it dropped? That's,
Do you have battery save mode turned on?
right.
Are you using the nice, expensive Apple charger for your phone, or are you using the cheap one from Walmart that only runs at half the rate? And why is my phone taking so long to charge? Well, because it turns out that there's only so much that you can do with the technology that you're given. And that's one of the things we're running into. But I think you guys have kind of hinted at part of it as well. It's inherent in the fact that we keep revising these technologies and making the numbers go higher, right? We went from, 802.11 AC to AX to BE, and then we started, well, that doesn't make sense to consumers. So let's call them Wi-Fi 5 and 6 and 7. Oh, wait, we did something with Wi-Fi 6, but it's not a different protocol. It's just a different spectrum. But what do we call it? We call it 6E. That's right.
But it's going to be the same standard.
But we dealt with the same thing in the cellular space, right? Because we had 3G, then we had LTE, which was 4G. But did you know there was a 3.5G? And AT&T was notorious for rating it as 4G, even though it wasn't.
That's how that came about.
But then, do we even know what the official acronym for 5G is, or does just everybody call it 5G?
NR.
But that's the thing, is it's become embedded in people to the point now where companies are trying to sell us on 6G, which isn't even a thing yet. So is it a part of this because people expect to see those numbers?
It could be. I guess my request to the industry is stop publishing them. Publish, yes, it's Wi-Fi 7. When Wi-Fi 8 comes out, put that it's Wi-Fi 8. We don't need to talk about the theoretical maximums that are completely unachievable in enterprise. If you want to put it, I get it. If you're buying it for home, at home I run really wide channels because I don't care about my neighbors, and I only have 3 access points in my house, and I can do whatever I want to. That you scale that beyond that, and all of a sudden my decisions that I made at home become a problem. So I think if it was just marketed as Wi-Fi 7, Wi-Fi 8, that would make life a lot easier. But
people just want to hear that they have the fastest one. And how do you prove that it's the
Wi-Fi
fastest
8 is
one?
definitely faster than 7, isn't it?
It is. If you have a client that can use it, do you have one?
Is it?
I guess that's my point. Like, does it matter? It's faster. It's 8 is bigger than 7. It must be better. It's challenging because we deal with it every single day in the real world, where we have to walk in and walk back those numbers and say, no, that's not possible. We're not going to run 320 megahertz channels in your hospital because, well, we'd only have 4 of them, and we have a lot more access points than that in the same RF domain.
How many times have we heard that Wi-Fi 5 is good enough? Because that was the high throughput. The speed-wise, looking at the speed, that's where we're at. Wi-Fi 6, Wi-Fi 7, beyond leaving out the 6 gigahertz because that changes things because it's another band of spectrum. But from a 2.4 and 5 gigahertz spectrum side, Wi-Fi 5 was good enough. Apple, on their Apple Watches, still puts Wi-Fi 5 radios in these to save cost because it's good enough. It does what we need.
But it's no different than when Intel was faced with the problem of all of their processors getting faster and faster, and they were hitting theoretical maximums of what the silicon could support. So how did they fix that? Well, then they, just like Wi-Fi, they said, well, it's not about the overall raw speed. It's about how much work you can get done. So that's when they said, well, why don't we put 2 CPUs on the same die, the Core series. And now when you look at Intel Xeon, can you tell me what the speed of the processor in your laptop is?
It's a great point. They stopped marketing it. They stopped marketing the gigahertz of whatever it is.
Well, not only that, but then they ran into a core count problem, right? Because now, well, if 4 cores is good, 6 must be better. 8 is really good. And I know somebody who bought one of those Intel MacBooks that had 8 cores in it and couldn't use it because it got too hot. Can you tell me how many cores there are in an M series MacBook? Nobody can, unless you read the spec sheet, because nobody cares. And did you know that most of them are actually not high performance cores? They're efficiency cores, because what they're trying to do is preserve battery life, and they've learned how to make a good enough machine. So do we need to get to the point where we don't care what Wi-Fi is in it? It's Wi-Fi 6, it's Wi-Fi 7, but I know people that have said, well, I'm not going to buy the new iPhone because it's not Wi-Fi 7. Well, okay, do you have a use case for it? Well, no, but I want the best one.
So the moral of this is we should just go to stop numbers altogether and just call it Wi-Fi?
Why not?
Yeah, let's just go back to calling it, it's just Wi-Fi.
I mean, I honestly haven't looked at Intel laptops for a while. They still marketing them as like i5, i7, i9, whatever.
They actually have done away with that branding
They
because,
do that.
yeah,
I think we can still keep the Wi-Fi 5, 6, 7, that number culture because that makes the marketing people happy. I think we can maintain that, but it's a shift in our thinking. We built this industry upon that. Wi-Fi A, B, G, and all the way up. That's how we built the industry. And so, as we were discussing earlier, we trained consumers to look for that.
Yeah.
It was us that taught them that. So you got to look. You want your best. Oh, you want Wi-Fi 7. I think maintaining. You don't necessarily have to get rid of the Wi-Fi 7, 8 piece as you move forward, because you do have to distinguish it, and it makes the marketing people happy. But the AEC, the AX, the numbers, all this stuff is the antiquated way of where we're doing this. Intel's antiquated way, they've decided we're done with this. With the Wi-Fi side, we should probably follow this.
but do you even need to do that? Because I reference Apple. Yes, we still have numbers after our iPhones, but the iPad does not.
True.
There is no version number of an iPad Air or an iPad Pro. There's a year that it was released, and you can tell them apart by the specs that are in. But they don't have version numbers because nobody cares. Because it's not about getting the next fastest one. It's not about getting a new one every year. It's about getting one that does my job. And my M1 still works as good as anything that I've ever had, and will continue to work that well until I decide to get rid of it. And it doesn't even have Wi-Fi 6. All right. I think that'll just about do it for this episode of the Tech Field Day podcast. As you can tell, we all know that the numbers are lies, and we just accept it, right? But it reminded me of a story that I told at lunch the other day about the VO2 max on my watch. I know that it's not right because I've been told by everybody on the internet that these things lie, but I don't care. Because if it lies, at least it's consistent with itself. So my VO2 max might not actually be 42, whatever that means. It could be 20 or it could be 60. But as long as it is the same number or a growing number or what have you with itself over the time that I've been tracking it, I don't care. And the same thing goes for the Wi-Fi speeds. I may have bought it based on the fact that it's super fast, but I know that I'm never going to see that speed. As long as it's fast enough for me to get the things done that I need to get done, provided internet conditions are not horrible, then I'm perfectly happy with a little bit of white lie now and then. Thank you for tuning in. Make sure that you follow us on all of the social platforms. You can always find the latest episode of this podcast on our YouTube channel at youtube.com/techfieldday. You can also subscribe in your favorite podcast application of choice. If you do, please leave us a rating and review so people kind of understand what we're all about around here. We're not your typical podcast. You can also go to techfieldday.com/podcast to view all of our episodes, as well as see the upcoming field day events where we usually record episodes like this. We will be back with more great discussions, premises on the Tech Field Day podcast very soon. But until then, take care and don't believe all the numbers that you see.